All right, here we are again. We're still in the January regions of last year, 2018. All right, here we go, Kylie. Number 27, not as bad as it looks. You have to read very carefully, particularly for the question, okay? This says, the distance traveled is equal to the rate of speed multiplied by the time traveled. Okay, that makes sense. Distance traveled is equal to the rate of speed multiplied by the time traveled. If the distance is measured in feet, okay, so we have distance in feet, and time is measured in minutes, then the rate of speed is expressed in which units? Okay, so speed, well, what would the speed be? If we're measuring distance in feet and we're talking about how far we go in minutes, what are we talking about when we talk about speed? We talk about how far we get in a certain amount of time, right? So regardless of all of this noise, these are the important bits in feet and in minutes. So if I'm going to talk about the rate of speed expressed in which units, it would be feet per minute. Now, explain means you have to use words. Explain how you arrived at your answer. You can just simply say, because it's asking for rate of speed, because speed is how far you can get in a certain amount of time. And that's enough, because it's really all about this first sentence in the problem. And we're done. But you know what? This is 1 point. And then whatever you say down here, as long as it makes sense, is another point. All right, moving on, because that's a lot easier than it looked, right? Now we have this crazy, let me pull this down. We have this crazy inequality graph, all right? Again, they give you all this space. You don't need it. Don't be frightened by that. This says, number 28, determine if the point 0, 4 is in the solution to the system of inequalities graphed below. Justify your answer. All right, so let's look at this. When I look at this, 0, 4, let's find 0, 4. Okay, x is 0 and y is 4. Look at all this crazy stuff. They tell me it's 10 up here, but if I look, I go 1, 2, 3, 4, 5. So there's 5 spaces to get to 10. That means each space must be 2, right? So I had to look at that graph and figure that out. So that's kind of a pain. So 0, 4 is, there's 2. Here is 4, right there. Well, it looks like an intersection point, so that's tempting. But you know what? I have to look at what that is. Look at that line. It's slashed. That means that any point on that line is not in the solution for this shading, whatever that is. It is in the solution, because this is a solid line, for this shading. But it's not in this one. So I have to say, determine if it's in. So you see determine, that means you have to say yes or no, by the way, or give them the point they're looking for. So the answer is no, because it falls on the dotted, or you can say slashed, line. So it's not in the solution. And that is literally it. That's all there is to that problem. Don't make it harder than it is, okay? That's probably the hardest thing to do, is not make it harder than it is. That's a real easy 2 points. And notice how far back in the regions that is that we're going. Whew. All right. These two are pretty gnarly, as it turns out. Okay, I'm only at 5 minutes in this video, so these two are pretty gnarly, but we're going to look at them anyway, just for a quick minute. This one says, if the zeros of a quadratic function f are -3 and 5, what is the equation of the axis of symmetry? Okay, wait a minute. Just looking at this, we haven't had a chance to talk about this year, but axis of symmetry, we know what that is, right? It kind of looks the same on one side and the other. Axis is just that line, you know, like that. Okay, so if I have a function, f, whatever it is, and -3 and 5 are my zeros, that means if I could graph it, right, then at -3 and 5 is where the parabola will cross. I don't know if the parabola is going up or down. It really doesn't matter. I'm just going to sketch a parabola here. As long as it goes through 3 and 5, I don't care. All right? But now line of symmetry means it's got to be exactly in between. So let's think about that. I want to put it exactly in between a -3 and 5. So if I look at that, 1, 2, 3, 4, 5, 1, 2, 3, right? So where's exactly in the middle? I'll just start here and count in. I go 1 in, I go 2 in, I go 3 in. Oh, there it is. This is the middle value, right? It's exactly in between. So that means the axis of symmetry is right there, all right? And I look at that. What's the value of x right there? That has a value of 1. My axis of symmetry is x equals 1. Now, if you don't get that equation when you're doing the graph, it's okay, the actual regions, because if you've shown this, and you've shown where you know the zeros are, and you know that the symmetry has to be dead in the middle, it's just logical. Symmetry, dead in the middle, okay? All right, and then we're going to look at number 30. Not too bad. Again, I'm hoping you're pausing this video as needed, okay? So I think I can do one more in this video so you don't have too many stops and starts. Wow, there's a lot of writing here. They tell you that this formula, and I'm not going to read all of those letters, but there's, you know, a bunch of different letters there, calculates the gravitational force between two objects, where g is gravitational constant, m1 is the mass of one of the objects, m2 is the mass of the other object, and r is the distance between them. Solve for the positive value of r. So we're solving for r. I want r to be all by itself. Obviously, it's got a lot of stuff on top of it like a hat. I want to get rid of that, okay? Here's what we do. I'm going to write it down again. So F sub g, which means the gravitational force, equals this big G and this m sub 1, m sub 2 over r squared. I'm going to show you a real slick trick. There's a 1 down there that we don't typically bother to write. So this should look like cross multiplication to you. Hopefully you see that, right? Interesting thing about cross multiplication, this only works if I have an equal sign here, okay? I have one fraction on one side, I have one fraction on the other. If I were to divide both sides by that mess and multiply both sides by that mess, but just this here in the denominator, what essentially happens is these two trade places. That is totally legal. So I can write r squared equals g m1 m2 divided by fg. Slick trick, but it absolutely works. Now, I'm good. I've got r by itself, but I only want to know r. I don't want to know r squared. But you already have 1 point here. What's the opposite of squared? If I look at my button, the opposites are written right on the buttons x squared, the opposite is that silly square root thing. So r is going to equal the square root, notice it's not squared anymore, of g m1 m2 over f sub g. But nonetheless, just recognizing that slick trick gives you a point, and then knowing to take the square root gives you the other. All right, that's enough for that one.